By the end of this module, you should be able to 1. Understand the hydrological cycle and how agriculture interferes with it. 2. Analyze the types and sources of agricultural water pollution. 3. Evaluate the impact of agricultural pollutants on human health and ecosystems. 4th, critically examine water-efficient technologies and pollution prevention strategies. 5th, interpret water quality assessment tools and indicators. 6. Explore policy mechanisms for controlling agricultural water pollution and improving irrigation efficiency. Water is the lifeblood of agriculture, yet it is also one of the most vulnerable resources under pressure from intensive farming. In this module, we critically examine the interplay between agricultural systems and water resources, delving into how unsustainable practices affect the quality, availability, and distribution of freshwater systems. From groundwater depletion to eutrophication, pesticide runoff to nitrate contamination, this module offers a panoramic and in-depth view of the hydrological impacts of modern agriculture. This module dissects the pathways through which agricultural pollutants enter aquatic ecosystems, including surface water runoff, leaching, spray drift, and soil erosion. Advanced topics include hydrological modeling, the nitrogen and phosphorus cycles, aquifer stress, non-point source pollution, water quality indices, and the integration of water-sensitive farming techniques. We will also explore international case studies, such as the dead zones in the Gulf of Mexico, nitrate-contaminated aquifers in India, and pesticide runoff in Latin America. Policy instruments like water pricing, pollution permits, irrigation subsidies, and global water governance mechanisms will be evaluated alongside innovative solutions such as drip irrigation, phytoremediation, and constructed wetlands. Agricultural water use. An overview. Water in agriculture. 70% of global freshwater withdrawals used for irrigation, differentiating green water, rain-fed, and blue water, surface groundwater. Irrigation methods, surface, sprinkler, drip, and sub-irrigation systems, water use efficiency, WUE, and irrigation water productivity, IWP. The hydrological cycle and agricultural disruption, natural water cycle, evaporation, transpiration, precipitation, infiltration, percolation, and runoff. Disruptions from agriculture, soil compaction reduces infiltration, excessive irrigation alters recharge patterns, modification of watersheds due to land clearing and leveling. Agricultural water pollution, pathways and types. A. Nutrient pollution, nitrates and phosphates, caused by synthetic fertilizers and manure, leads to eutrophication, algal blooms, hypoxia, and fish kills. Blue baby syndrome, methemoglobinemia, caused by nitrate-contaminated drinking water. B. Pesticide and herbicide pollution. Runoff and leaching of agrochemicals contaminate rivers, lakes, and groundwater. Persistence and bioaccumulation in aquatic organisms. Atrazine, glyphosate, chlorpyrifos, commonly found in surface water. C. Sedimentation, from erosion of unprotected soils during rains, clouds waterways, disrupts aquatic habitats, transports bonded chemicals. D. Salinization of water bodies, accumulation of salts due to irrigation water return flow. Reduces soil and water usability, especially in arid zones. E. Pathogens from livestock operations. Fecal contamination of waterways, outbreak of E. coli, Giardia, Cryptosporidium. Antibiotic-resistant genes from CAFOS, concentrated animal feeding operations. Non-point source pollution. Unlike point source pollution, agricultural runoff is diffuse, episodic, and weather-dependent. Challenges in tracking and regulating NPS pollution. Use of models, SWAT, Soil and Water Assessment Tool, AGNPS, Agricultural Non-Point Source Model. Groundwater depletion and contamination. Over-abstraction of aquifers for irrigation. Unsustainable water table declines. India, China, US Ogallala aquifer. Leaching of nitrates and pesticides into groundwater reservoirs. ecological impacts of agricultural water pollution, aquatic dead zones and biodiversity collapse, disruption of trophic interactions in rivers and lakes, bioaccumulation and biomagnification of pesticides in food chains, impaired ecosystem services, e.g., water purification, fishery productivity. Water quality assessment tools, physicochemical indicators, pH, BOD, COD, nitrates, phosphates, TDS. Biological indicators, presence of sensitive macroinvertebrates, EPT index. Water quality index, WQI, pollution load index, PLI. World Health Organization and Food and Agriculture Organization standards for safe irrigation water. Mitigation strategies and best management practices. A. Efficient irrigation techniques, drip and subsurface irrigation reduce runoff and water loss, sensor-based and AI-controlled irrigation scheduling. B. Nutrient and pest management, integrated nutrient management, INM, integrated pest management, IPM. Use of biofertilizers, slow-release fertilizers, precision application. Chapter buffer zones and riparian vegetation. Vegetative filter strips trap sediments and nutrients. Wetlands act as biofilters. D. Constructed wetlands and phytoremediation. Engineered ecosystems that mimic natural wetlands. Use of aquatic plants to absorb nutrients and contaminants. E. Policy and governance tools. Water pricing reforms to discourage wastage. Regulation of agrochemical use near sensitive zones. Incentives for farmers to adopt clean water practices. Participation in global water compacts and frameworks, e.g. SDG 6. Case studies of agricultural water pollution. Chesapeake Bay, USA, NPS pollution from agriculture. Gulf of Mexico, hypoxic zone from Mississippi River, nutrient runoff. Punjab, India, pesticide contamination and cancer belt. Lake Victoria Basin, eutrophication from upstream farming. Innovations and future outlook. Remote sensing and UAS for runoff mapping. Water sensors and I for nutrient and irrigation optimization. Blockchain for water resource governance. Climate smart agriculture integrating water resilience. Key terms to remember. Eutrophication, non-point source NPS pollution hypoxia, agrochemical leaching, groundwater overdraft, constructed wetlands, buffer strips, integrated water resources management, IWRM, salinization, blue baby syndrome,